Howdy, howdy. Welcome to Naming Molecular Compounds and Finding the Formulas for Molecular Compounds. This fits with Science 9, Matter and Chemical Change. Let's get started. All right, my friends. So first things first, what is a molecular compound? A molecular compound is when two non-metals form a bond. Now, the kicker with these is that the non-metals need to be atoms. So what that means is they have not lost or gained electrons or anything like that. I'm just trying to find my pen. Give me a second. There it is. Alrighty. So they're atoms. Now, because they are atoms, that means they're not taking an electron. They're actually sharing electrons. Remember, ionic compounds are two ions where one ion takes electrons from the other ions and they go whoops, stick together because one is positive and one is negative. Now, when you have two non-metals, they actually share electrons. That looks like this. So we look at the bonds that are taking place here. Oh, look, it's so nice. The carbons and hydrogens are holding hands. They're sharing the electrons because ionic compounds are made from ions, molecular compounds are made from atoms. All right, now because there is no charge, we have to use something called a prefix. A prefix tells us how many of each atom is in that compound. So for example, if I have one of that atom, I use the word mono. If I have six, I use hexa. This chart is really important. The more you practice, you start to memorize it because eventually you don't get this chart. You just got to know that penta is 5. Let's get started. How does this work? So here's my beautiful compound. The first thing I do is I break it apart. I break it apart. My two capital letters represent two different atoms. I go to my periodic table to determine, is it ionic? Is it molecular? Over here, I find that here is my carbon and here is my oxygen. They are both on the non-metal side. Therefore, it is molecular. So I'm going to pull those two boxes out for you. So what I have here is the C for the carbon and the O for the oxygen. Now, just like an ionic compound, you have to truncate or break off that second word and make it IDE. And the other kicker is this. I have two oxygens. So I got to remember, I got to use that di. So the difference between the chemical formula and the chemical name is that that di goes in front of the element that I'm talking about. So I'm going to truncate my word and I'm going to put the di in front to get carbon dioxide. Okay, next one. Here we go. Break it in half. I go to my periodic table and I make sure that it is molecular or ionic. So the first thing that I see is that here's my sulfur and my oxygen, both on the non-metal side. Therefore, it is molecular. Let's pull those two things out. So S is sulfur. I got my trusty chart over here because it's molecular. My O is oxygen. So when I write them there like this, I remember that I have a 2 here. That means I have to say how many oxygens do I have. So I go over to my trusty chart and I say it's di. The next thing is I take my vowel, so E, Y, and I break it off here. So I get sulfur dioxide. Let's try our next one. Break it in half. These are all binary compounds. Binary means 2. All right, I'll go to my trusty periodic table to see, is it ionic? Is it molecular? What could it be? I look and I find here is my nitrogen, group 15. Here is my oxygen, group 16. They are both non-metals. Therefore, it is molecular. So they're going to share electrons. Okay, let's pull those little lovely tabs out. So as we can see, my N is nitrogen. My O is oxygen. Why is that trusty table here? Because I cannot balance the charges. So over here, I have blank nitrogen, blank oxygen, because I have different subscripts here. So I go to my table, 2 is di. I go to my, so I put di goes in here. I go to my table because 3 is right here, is tri. So tri would go right here. And don't forget, I have to truncate my second word, only the second word, and that is it. So I go with one vowel, second vowel, bam, break it off. So I get dinitrogen trioxide. Notice I'm not putting a state after these. Ionic compounds are always solid at room temperature, but check this out. Molecular compounds can be, what's that? Solid, liquid, and gas? Oh, no, she didn't. That's right. So I don't expect you to know what state they are, but as you practice these, you will start to know if they're solids, liquids, or gases. All right, let's try this one. Break it in half. Go to my periodic table. I find carbon here. I find oxygen here. I pull out my trusty little periodic table things, and I see that carbon is C is carbon, and O is oxygen. Now, I put my carbon blank oxygen. I notice that I don't have any number there. So that means it's 1. So it's going to be mono. So I put the mono here. Now, if you look at my answer below, you'll see that I actually have 1 O. We never put 2 O's together or 2 A's together. And so that's an important thing. So you drop one of the O's. Remember, to get my IDE, I go 1 vowel, 2 vowel, bam, break it off. All right, what's that mean? Other direction, my friends, chemical formula now. So same thing, I break it where my space is in between my 2 words. I'm going to go to my periodic table and find them. So I see here's my sulfur and here is my fluorine. I think it was fluorine. Oops, oh, it was chlorine. Same thing, both halogens. Here's my lovely trusty periodic table boxes. So I look over here, I have this chart. You need to always have this chart because once again, they're sharing electrons. You can't balance the charges. We have to tell people what charge we're using. So sulfur, my symbol is an S. And now I need to break this up. I have 2 parts here. I have the tetra, and I go over here. Tetra is 4. And then I have the chlorine or chloride, which is chlorine. So tetra is 4, chloride or chlorine is Cl. So to write my formula, because I only have 1 sulfur, I do not put a 1 there. It just becomes, oh, that's terrible. We're going to pretend that's not there and go SCl4. Everyone makes mistakes. I've been copying and pasting lots, but it's SCl4. Notice I do not put a 1 here, right? Never ever put a 1. The minute you draw that symbol, we're under the assumption that there's 1 element there. All right, next one here. Nitrogen monoxide. We're going to break it here like this. Go to the periodic table to prove that it's molecular. Here's my nitrogen. Here's my oxygen. Yep, they're both on the non-metal side. Therefore, it is molecular and they're sharing electrons, right? 2 atoms sharing electrons. Let's find our symbols, pulling it out. So nitrogen symbol is an N. And then I look over here and I have that beginning part, so mono. So I got to look where mono is, and mono means 1. And then here's my oxide or my oxygen. So mono is 1, oxide is O. So to write my formula, I just put them together and I get, no, I know, hilarious. You're welcome. I'm here all day. What can I say? Notice that I don't put a 1 after any of these. And that's because the minute you write the symbol, we are saying there's 1 of those there. Otherwise, if there was none, you write every single one of the elements in your formula, which would be crazy. Next one, phosphorus trichloride. Bam, break it in half of that spaces. I go to my periodic table, confirm that it is molecular. So I have phosphorus and I have my, over here, my chlorides. So I'm going to pull them out like this. So my symbol for phosphorus is P. Here's my trusty chart again. And then I have to double check. I have that tri here. So what does that tri mean? Tri means 3. And then here's my chloride. So it's really, really, really important that you see that. Over here, my formula is PCl3. All right, how do we do this, my friends? Easy peasy lemon squeezy. So first things first, molecular compounds are made from 2 non-metals. They are atoms. They share electrons. The formula to the chemical name, you find the name and you change the second non-metal to end with IDE. Okay, don't forget to add those prefixes in there if you have to tell you how many of each atom that you need. To go from the name to the formula, you find the symbol and you use the prefixes to find the subscripts. Thanks for watching, my friends. Have a scientific day.